with the central bright band itself. This is the difference between the interference and the diffraction. In the interference, what happens? Each and every fringe will have the same intensity. It will maintain the same intensity, same bright band, same intensity of bright band, same intensity of dark band, same intensity of bright band, same intensity of dark band. But in the case of diffraction pattern, it will not happen. So only 1/3 of the slit is going to reach the point P. That's why what happened? You are going to get the bright band, but the intensity is not that much as like the central fringe. Okay, this is called the first secondary maximum. Next we are going to discuss about the second secondary maximum. Second secondary maximum means n is equals to how much you have to take? 2 you have to take. N is equals to 2 you are taking. Then what happened? It will become 5 lambda by 2. That means the path difference delta x is equals to 5 lambda by 2. When I want to refer to the 5 lambda by 2, then the diagram will be given like this. This is the source I am taking here. Okay, here the same screen I am going to be extending. This is A and this is B, and you are going to be locating the point, and these are the individual source of lights, and one light is going to be reached at this point and another light is also going to reach at this point. This time what is the path difference is 5 lambda by 2. 5 lambda by 2 means if I am going to take a perpendicular line at here, what is the path difference? Delta x is equals to 5 lambda by 2. When I am going to take the 5 lambda by 2, this time how many parts I am going to divide? The slit will be divided into how many parts? 5 parts. If I am going to divide into 5 parts, this is the first part, second part, third part, 1, 2, 3, and this is the parts you are going to take. 1, 2, 3, 4, 5 parts you are going to be dividing itself. When you are going to divide into 5 equal parts, then what is the path difference will be? Each between them will be 5 lambda by 2 will be takes place. Lambda by 2, 2 lambda by 2, 3 lambda by 2, 4 lambda by 2, 5 lambda by 2. Like that the path difference are going to be produces. Now listen very carefully. What is going to be happens here? Again same 100 sources you are taking. These two produces, these two is going to be superimposed. What is the path difference? Lambda by 2, dark band. These two are going to be superimposed on each other. What is the path difference is? Lambda by 2. But for this last one, is there any other sources are there to superimpose? No other sources are there. That's why this band is going to reach the point P. Because for this patch, there is no other patch is there to superimpose. For this one, these sources are there to superimpose. For this one, this source is there to superimpose. And path difference between these two is lambda by 2. Path difference between these two is also lambda by 2. So that's why what happened? These 4 bands are going to be interacting. They are going to produce a dark band. But the 5th band, there is no possibility to get the interference. That's why this band is going to reach the point P. Then what happened? It is dark is there and this bright is going to interact at here. Definitely what happened? You are going to get the bright band. Again, what about the intensity? Is the intensity is that much to the first secondary maximum? No. The intensity will be less than the first secondary maximum. So what is the reason? Because at the central time what happened? The total slit is participating to produce the bright band. But in the first secondary maximum, only 1/3 of the slit is producing the bright band. In the first secondary maximum, only 1/5 of the slit is going to be producing the bright band. So that means what happens? Every time what happens? The bands increases, the intensity of the bright band decreases, and gradually after some time what happens? You are not going to get any bands itself. That means in the interference pattern, in the diffraction pattern, obviously maximally what happens? You are going to get 3 or 4 bands are going to be produced. After that, bands are going to be disappears. The reason is the slits are going to be changing, or widths are going to be changing here. Okay, in this way what happened? The diffraction pattern, the fringes are going to be obtained itself. Okay, why the dark band and why the bright bands? It is a very important one. Okay, listen very carefully. First what happened? Exactly opposite to the slit, you are going to have the central maximum. Okay, central maximum. The intensity will be maximum. Okay, after that immediately you are going to get the first minimum. Okay, in the first minimum what happens? The dark band is going to be produces, and next immediately first secondary maximum. Okay, what are we going to get? First secondary maximum. Okay, only 1/3 of the slit is going to produce the bright band, and next one you are going to have the second minimum. After that second secondary maximum. In the second secondary maximum, only 1/5 of the slit is going to be produces the bright band. If I am going to take the next one means if I am going to take the 3, n is equals to 3. 2 into 3, 6 plus 1, lambda by 2, 7 lambda by 2. When you go to refer to the 7 lambda by 2, then immediately what happened? The slit, 1/7 of the slit only is going to be produced the bright band. That's why bands are going to be decreases. Sometimes what happens in the examination, they will ask you that in the diffraction pattern, why the intensity of the bright band gradually decreases. The reason is the central band, the full width of the slit is participating. But in the first secondary maxima, 1/3 of the slit is producing the bright band. In the second secondary maxima, 1/5 of the slit only producing the bright band. That's why the intensity is gradually decreases itself. Okay, this is the complete part of the diffraction pattern you have to remember. Today we are going to discuss that how the bands are going to be produced, what is the path difference conditions, and based on this path difference condition, how can we explain the bright bands and the dark bands are going to be produced here. Okay, that's all for today. In the next class we can discuss about the fringe width and what is the central maxima, width of the central maxima. All those topics we can discuss. Okay, thank you.